So we've referenced half-life a couple times, and tonight we're going to talk about exactly what half-life is. So half-life is kind of a way to measure the amount of time it would take a radioactive sample to decay to a certain amount. So a half-life is the measurement of how long it would take a sample of a radioactive material to decay by half. So for example, if we had a 10-gram sample, it would be how long it takes it to decay to 5 grams. And so here's the decay series for uranium-238, and we can see a list of the half-lives right there. And so if we look at uranium-238, for example, its half-life is 4.47 billion years, so a very, very long half-life. That means it would take about 4.5 billion years for half of the uranium-238 to decay. Other ones are really, really short, like polonium-214, which decays half-life is 0.000164 seconds, so a very, very quick half-life. So the trick with half-life is always the time that it takes for half of something to decay. So for example, if we look at lead-210, if we've got a sample of lead-210, let's say we've got a 10-gram chunk, a nice even number. So the half-life for lead-210, which we symbolize with T subscript 1/2, is equal to about 22.3 years. So if we have that 10-gram sample, after 22.3 years, how much will be left? Yeah, 5 grams. Now, what you might be tempted to say then, okay, so then after another 22.3 years, that means the other half is going to be gone. But that's not true. So after 22.3 years, half of this will now have decayed, so we'll be left with 2.5 grams. And so it divides in half again. And after another 22.3 years, you're going to be left with 1.25. And it keeps going till eventually you get to 0, or a number that you can't really logically divide in half again. So to visualize this, we'll set up a graph. On the y-axis, we'll put mass in grams, and on the x-axis, we'll put time in days. And we'll do this for lead or bismuth-210, which has a half-life of about 5 days. So let's imagine that we start with a 20-gram sample, and so that would be at time 0 right there. Now, if the half-life is 5 days, that means after 5 days, half of that would be left. So we'd be left with 10 grams after 5 days. Now, after another half-life, which would be 10 days total, we would be left with half of that. So if it was 10, now it's going to be at 5. And after another 5 days, which would be another half-life, total of 15 days, we'd be left with half of that. So half of 5 would be about 2.5, so it would be somewhere in there. And after another half-life, which would be at the total of 20 days, be left with half of that. And that's about 1.25, so that's down there. And after another one, it'd be very, very tiny, and so we could keep going down until you eventually run out. But what you can see here then is that the graph that's created is curved. And so it's not just a straight division, and you're eventually going to run out, but it divides really, really quickly at first, a little bit less, then a little bit less, then a little bit less. And so we create an exponential curve that's very indicative of a half-life. Now when you solve half-life questions, there's 2 ways to really do it. One of them, it takes a little bit longer, but it's much, much easier math. So if you're weaker with math, it's a good route to go. Another one, it's a little bit quicker, but it also deals with some pretty complex math. So if you're good with math, that'll be your choice. So the next 2 videos I have posted, one goes over the more complex math route, and the other one goes over the little bit longer but easier route. You can choose which video, and you can even choose which method you want to use. Watch them both if you want to, and you can pick. Both of them work, both of you get to the right answer, but they get there through different routes.